Hey guys, this is my attempt to show you how to do an ACSL strings problem. Please excuse the background noise. I also ask that you would bear with me on the lack of focus. Not exactly sure why this document camera is not as focused as it should be, or what it is focusing on, if it's not focusing on the letters, but um, I've given you a copy of the problem that I'm working on, the two problems that I'm working on as an intro to this topic, and I'm just going to uh, try to do a problem for you. Hope the camera doesn't fall apart on me, and we'll see what we can do about that, and if you have any questions about it. First of all, you have access to Axel's link to what does this program do, WDTPD, the topic, and we're focusing on the strings subset, which is our final subset for the year. You already know C++ strings. You know what a string is. You know that it's text. You know that text that's in quotes is considered a string by most programs. You also know that strings are subscripted, like arrays. They are in C++. You learned that C++ strings were subscripted as characters, the individual letters, individual characters in a string, letters, punctuation, spaces, digits, were chars. And so one difference in the ACSL strings that we're going to be working with is that they're not chars. They are and they aren't. Okay, the individual character type when you subscript an ACSL string is still a string, whereas in C++ it was no longer a string; it was a char, and we could use the numeric value of that. The sense in which they are still chars is that they have a value, a lexicographical value, an ASCII value in a sense, where A is low and Z is high. And so if you are comparing two strings, especially if it's two individual characters in a string, then you can use less than, greater than, equal to for comparison, or even not equal to compare two strings to generate a true or a false. And if you were to compare an A to a B would have a higher value than an A, and A would have a lesser value than a B. Okay, and so you have to keep that in mind. The subscripts, I don't know if you can see this here. Okay, it says A and then subscript J colon J. That's an awkward way to indicate that you only want one character, one subscript in that range. The range is from J to J. And so that just means you only want one character, and that's just how they're going to be using it. And so that's a range, which means the subscripted range could actually be more than one character. It could be, J's value. J in this situation is a loop counter. Okay, and so J to J, whatever the first character is, it just wants that one. Anyway, so what are we reading here? This says X equals, and then you have an open quote and a closed quote. Same for Y. They're being set to something called the null string. Okay, these are each being set to string values that are of 0 length. It's a valid string. Okay, it's not null in the sense that there's nothing there. It's null in the sense that it's an empty string of length 0. And that's common for these kind of problems, as a starting value for a string that's going to be built up. We have 3 strings here. So we have the 2 null strings, X and Y, in this particular problem, where it's asking what the value is printed at the end. Here we have a print command. You know that to be like C++'s cout command. So whatever y's value is at the end of this thing, that's what we're going to put over here, y equal whatever the final value is. And we have a third string, A. A is a string that is just United States of America, no spaces. Okay. Then we have a for loop that goes from here to here, followed by another for loop. They are independent of each other. They are not nested. One is not nested within the other. Okay. So this J loop is going to run its full course before the K loop begins. And then when those two loops are done, we'll have a value for Y at the end, which we will display in the solution part. Okay, so why don't we just go ahead and try it out. I'll explain some of the symbols as we go. But so we have United States of America. Now, when you see the command len in this context, and then something inside of that, which is presumed to be a string, in this case down here, it's len, and then inside of that is a string, not just a subscript of the string, but a string. I'm used to actually seeing that in parentheses. What it wants to know is the length of string A. And we've already pointed out that string A is the words United States of America with no spaces separating the words. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm numbering these because we're going to need those numbers later. 10, 11, 12, 13, running out of places to mark these, 14, 15, 16, 17, 18. I hope you guys can see this. 19, nope, that was 18, 19, 20, 21. If I have counted correctly, it looks like the length of string A is 21. Now, that's tucked inside. Oh, let's go back here. J equals 0 to the length of 20, to length of string A minus 1. So basically, we're doing J equals 0 to 20. Okay, so this value is just one short of the string, the original string length of A. For J equals 0 to length of A minus 1, so 0 to 20. If A sub J through J, so whatever J's value is, in this case it's 0. So we got if A sub 0 is greater than A sub the length of A minus J. Okay, so what was the length of A? The length of A was 21. Minus J, what's J's value? 0. So this is 21. You can see that, okay? Minus 0. Minus 1 through, see the colon there? 1 through the length. Is that what that really means? This is really kind of funky looking. Okay, but minus 1. Let's just say minus 1. And colon through the length of A, which we know to be 21. 21. Actually, yeah, 21 minus J, still 0, minus 1. Wow, what a long, awkward way to just say A subscript 20. Because it's 20 through 20, which is just A subscript 20. Okay, what do they want us to do with that? Oh, that's just saying if A subscript 0 is greater than A subscript 20, then we're going to do something over in this then part. We're going to do something about that. Okay. Looks like we're going to take X, which is the null string here, and set it to whatever X currently is at. See here? I hope you can see that. X, we're going to set that equal to whatever it currently is plus A sub JJ. So if A sub JJ is bigger than what it's being compared to over here, then we're going to add it to the X string. Well, let's figure out what A sub JJ is. J was 0, so it's the very first character of the string. So this is a U. You see that? Let's move up. That's a U. All right. It's supposed to be a U. Okay. And the 20th, is it really the 20th? Shouldn't be the 21st. 21 minus 0 minus 1. So it's 20. Why not 20 instead of 21? I'm going to pause this. Okay, yeah, it wants 20 sub 20 because of the off by 1 numbering in the array. So the basic problems in ACSL did not used to be that way. They used to start at 1 and go all the way to the length of the array. But in recent years, ACSL has changed their arrays and strings, and certainly the strings here, so that the first one is subscript 0 and the last one is subscript length minus 1. So that's what they're doing here. So they are comparing the very first character in the string United States of America to the very last character, which would be, I should have numbered, instead of numbering these 1 through 21, I should have numbered them 0 through 20. Okay, so we're just going to have to keep that in mind as we go through this, that the actual subscript value of the first one is really a 0, the second one would be 1, and the last one, instead of being 21, would be 20. So that's what they're doing here. And we come down here and we're asking if U is greater than the last character, which is the A at the end of United States of America. And oops, gotta write that down. Okay, and lexigraphically, U, because it comes further down the alphabet than A, is bigger. If you think of A as a 1 and a Z as a 26, well, then U is going to have a value that's closer to 26, isn't it? So this is going to be a true, which means we do have to come back here and do the then part of this if statement, which is to concatenate. There's our concatenation operator there. Plus is always concatenate in strings when you're using it with strings. Okay, we're going to concatenate to X's current value, which is just the null string, the character that we compared on the left, which was the J through J character, which in this case was 0 through 0, just the 0 subscript character. Wow, that's a mouthful. Okay, but it's going to take the U and concatenate it. So now X has a value of null plus U, which just means it's now U. Okay, so after one pass in this J loop, in this first for loop, the X string has been extended to just a U. Okay, and we're at next J, and we come back up and we ask ourselves, okay, J is going to increment to, since there's no step, the step is automatically by default +1. So J's value is now equal to 1. And we come in and, you know, what we're going to try and do is get a pattern for what's happening here. And once we see the pattern, we're just going to be the smart humans instead of the dumb, fast machine, because we're too slow to be, you know, keep up with the machine. But we're smarter than the machine. We're going to figure out what's this algorithm doing, and then we're going to speed things up a little bit. Okay. So what is it doing? Well, it's going to go to the next character, which is A 1 through 1. Okay, or A subscript 1, which is actually the second character in our off by 1 numbering. So now we're comparing, you know, for J equals 0, we compare these. For J equal 1, let's see that, shoot.